In this video, we're going to go over a few examples of using the quadratic formula to solve quadratic equations. As a quick reminder, we can use the quadratic formula when we have an equation where ax squared plus bx plus c equals 0. We're in general form and we're equal to 0. If we have that case, then the solution is x equals the opposite of b plus or minus the square root, b squared minus 4ac, all of that over 2a. So let's look at a few examples. First example, we're just going to solve this equation. 3x squared plus 7x plus 10 equals 0. We are in general form, but we don't equal 0, so our first step is to fix that. So we'll subtract 8 from both sides. We get 3x squared plus 7x plus 2 equals 0. Now we're in general form. We equal 0, so we can use our quadratic formula. I'm going to start off just by identifying A, B, and C. A is 3, B is 7, C is 2, and I'm just going to plug it into my formula. X equals the opposite of 7 plus or minus the square root. 7 squared minus 4 times 3 times 2, all over 2 times 3. Now, if you're good enough with your calculator, you can plug that straight in, but it's not a bad idea, especially if you're somewhat iffy, to go through and take it in a few steps. So we'll first evaluate what's in the radical. 49 minus 4 times 3 is 12, times 2 is 24. 2 times 3 is 6. So that gives me a negative 7 plus or minus the square root of 25 over 6. Negative 7 plus or minus 5 over 6. So this plus or minus means we have to get two answers. 7 plus 5 over 6 is negative 2 over 6 is a negative 1/3. Negative 7 minus 5 over 6 equals a negative 12 over 6 equals a negative 2. So my two solutions to my equation are negative 1/3 and negative 2. So let's see what else we can do. On this problem, I gave you an equation, y equals 2x squared minus 5x plus 8. And in this case, we're looking for the roots and the vertex. Now, I can find the roots by trying to put it in factored form if it factors easily. I can do the vertex by completing the square. Factoring doesn't always work. Completing the square always will. But I'm going to use the quadratic formula to do this. So I'm going to start off finding my roots. So again, when I'm looking for the roots, I set y equal to 0. So I get 0 equals 2x squared minus 5x plus 8. And now, again, I can use the quadratic formula because I have 0 equals a quadratic in general form. My A is 2, my B is negative 5, my C is 8. So when we plug this into the formula, x equals the opposite of negative 5 plus or minus the square root of negative 5 squared minus 4 times 2 times 8 all over 2 times 2. Now we got to be a little careful when we have this b value being negative. When we take the opposite of b, we're not going to get a negative number. The opposite of a negative is positive. Other thing is be careful with your calculator. When we square negative 5, we should get positive 25. But if you plug it into your calculator without the negative, it will give you a negative 25 and will mess you up if you try to plug it all in at once and aren't careful about what you're doing. So let's move on to the next step. X equals 5 plus or minus the square root of 25 minus 64 over 4, which is 5 plus or minus the square root of negative 39 over 4. Negative 39 is, oh, well, it's negative. I can't take the square root of negative 9 with real numbers. So this one does not have real roots. The roots are going to be 5 plus I times the square root of 39 over 4, and 5 minus I times the square root of 39 over 4. So these are complex. They're not real. So these roots are not going to cross they're not zeros. Well, there are zeros. They're not going to cross the x-axis. When we look at this graph, it's going to be somewhere above the x-axis going up. It will never cross. So that's the roots. We can still find the vertex, though. And we can do that with this information we have. Again, this is going to look something like this. We're going to have I know it's going to open up because my A value is positive. So the vertex has to be above the x-axis going up. I can't show these two roots on the graph, but I do know for any two values, for any value on the parabola, it has a matching one. And if we go halfway between those, we're doing weird things here. Halfway between there, we'll find the axis of symmetry, and we can find the vertex. I can do this idea even if the roots are not real. So what I'm going to do is average my roots. So I'm going to take 5 plus I times the square root of 39 over 4 plus 5 minus I times the square root of 39 over 4 and divide that by 2. Well, I already have a common denominator. That's kind of nice. So I'll make this all over 4. And a positive I square root of 39, negative I square root of 39 will cancel out. So I'll really get 1/2 of 5 over 4, or 5 over 8. This is the axis of symmetry, and this is the x-coordinate of the vertex. To find the y-coordinate, I just plug that into the equation. Y equals 2 times 5/8 squared minus 5 times 5/8 plus 8. And that's going to give me 5.656. So my vertex is going to be 5/8, which is 0.625, 5.655. And you can plug that into your calculator, graph the equation, and trace it down to this point. You will find that, yes indeed, this is the vertex. Let's finish off with a story problem. This one's also dealing with the gravity equation. So we have Daisy up on top of a 50-foot building. She kicks a ball off the top of the building. She kicks it with a vertical velocity of 12 feet per second. And we want to know, when is the ball going to get down to 25 feet? When is it going to hit the ground? And how high does the ball get? So, in order to do this, we're going to need our gravity equation. And if we are in feet, we're going to use the value of acceleration of gravity of 32 feet per second. And that gives us this equation. The height at any time t is a negative 16 times the time squared, plus the starting velocity times the time, plus the starting height. So if we look at our problem, we have our starting velocity is 12 feet per second, and our starting height is 50 feet. So our equation that we're going to use for this problem is h of t equals negative 16t squared plus 12t plus 50. So let's go through this. For part A, I'm looking, where does my height equal 25 feet? So I plug that into my equation. 25 equals a negative 16t squared plus 12t plus 50. Like on our first problem, we don't equal 0, so let's get rid of that. Subtract 25 from both sides, and we'll get 0 equals negative 16t squared plus 12t plus 25. And this is something we can plug straight into our quadratic formula. And we'll get undo. The time equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. And if you take a second, plug that into your calculator, you should get that t equals either negative 0.93 or 1.68. So we can't have a negative time. So it's going to reach 25 feet at 1.68 seconds. So now let's look at part B. So for B, when will the ball hit the ground? The ball will hit the ground. Draw. When the height equals 0. So we will just say 0 equals negative 16t squared plus 12t plus 50. And now we're all start off equals 0, so we can go straight to the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. And if you take a second, maybe pause the video, plug this into your calculator, check your answers with mine. But I got that the time is a negative 1.43 or 2.18. And again, we're going to take the positive time because we can't say it hit the ground before we kicked it. So this is 2.18 seconds. But I'm going to keep an eye on this other time because that's going to help us with part C, as we did on that last example. Because now we need to know how high the ball gets. For this final one, we want to know how high the ball gets. We're looking for the vertex. So again, we'll use the idea the vertex is going to be halfway between the two roots. So I'm going to average my roots. So I'm going to say the vertex is when t equals a negative 1.43 plus 2.18 divided by 2. And that's going to be at 0.375 seconds. So if I know what time the ball is at its height, I can just plug that into my equation. Height at 0.375 is going to be negative 16 times 0.375 squared plus 12 times 0.375 plus 50. Take a second, plug that into your calculator, and you're going to get 52.25 feet. So the ball is going to get 52.25 feet into the air. Quadratic equation, or the quadratic formula, is very versatile. You can answer a lot of problems with it. You can find the roots, you can find the vertex, you can find any value you want if you use it carefully. But again, use it carefully because it's so easy to mess up that formula when you're plugging it into your calculator.